Welcome back, Precalcsters. What I want you guys to do for me, I'm going to give you 2 minutes to discuss and start a problem. Here's the deal. I've given you every little bit of background stuff that you need to do it, but we haven't done a problem like this. That will inevitably happen. I give you all the tools, and I try to give you as many examples of types of problems as possible. I want you guys to do this for me. I want you to find the quadratic with, or find the parabola with, let's pick its vertex. Dolan, other than the origin and a quadrantal point, so something in a quadrant somewhere, where do you want the vertex of this parabola?
5, 2.
Okay, love it. We have a vertex at 5, 2, and Matilda is going to give me a point on the parabola that also doesn't have a 0 anywhere in it.
6, 1.
Thank you for not giving me 6, 7. Appreciate it. Okay. I want you guys to start. You're going to find me the parabola whose vertex is at 5, 2 and the point 6, 1 on the graph. Now, just to be clear, I don't mean that there's just some random point floating on the coordinate plane. This is on the graph of the function that we can call y or f of x. Okay, this is all that I'm going to give you for now. We're going to go about 2 minutes. If you want to start solving it, I'm cool with that. If you want to talk about it, I'm cool with it. If you start writing and you're on the wrong track, it's okay. Just make note of what didn't work so we avoid it in the future. 2 minutes. I'm going to go find a 2-minute song. Talk it out. Okay, we have the vertex or the standard form of a quadratic. Will somebody just recall what that is for me without looking up at the board?
X minus h squared.
You're close.
F of x.
You forgot one thing.
A.
A.
X minus h squared plus k.
All right. What is h and k?
The vertex.
So,
You
ooh,
have the vertex.
I do. I have an h and a k. So check it out. We're going to take 2 steps here where you might have done 1 step. What is h
5.
and what's k?
0.
All right. So now, unfortunately, we have 2 unknowns. 3 unknowns. Geez, in one equation. That sucks. If only I had an x and an f of an x. F and x. F. Oh my gosh. An x comma f of x or an x comma y to plug in. Oh, what's this? That's x and y, right? Well, f of x is interchangeable with what? With y. So what should I plug in for this f of x? 1 for that f of x, because that's a y value. And that's the y value when x is what? And check it out. I'm going to keep h and k in here. The only thing we really needed was this value of a to get our equation. Boom. Can we solve this for a?
Yes.
Help. What do you do first? So I get -1 equals a times 1. Well, that was quick. You could. I'm not going to.
It's still squared though, right? It's just 1.
It is still squared. I'm sorry. Yes, thank you. Good point out. Thank you. But it's still 1. We got a, right?
Yeah.
Do we need anything else? Okay, well, here we go. F of x. What was a? Am I really going to write -1?
No, negative.
Negative x minus, what was h?
5.
Squared plus?
2.
We done. It is that easy. Yeah, absolutely. I was hoping it would be uglier because I just made it up, but it wasn't. It's awesome.
Is it okay if we put f of x equals x squared minus 10x plus 2? Or do you leave it as profitable?
It would be -23. Otherwise, I agree. Because you would get this would be +25, and then we distribute the negative, it'd be -25 plus 2. You could absolutely go to that more general form, 100%. My biggest statement on that, Red, and great question, by the way, don't do more work than you have to. All right. On B, I'm going to make sure that A is not just 1 or -1. You guys can do one more. The vertex, which will henceforth, I'll just write vert here. We're going to say the vertex is at -2, -1. And do you guys prefer the number pi or e?
Pi.
Okay, well, I'm not going to use either of them, but thank you to whomever just said that. -2, -1. And let's say we also get the lovely point, I don't know, let's make one up. F of 3 equals 7. Cool. I don't know the answer. I just made this up so it's going to be ugly. I don't know for sure that it will be. Independently, or you want me to call in random people? Okay, I'm going to give you guys like a 60-second head start, and then I'll start working it. Once we get the value of a, we're done. F of x is just the lovely function 8/25 x minus a negative 2, or x plus 2, squared minus 1. We're done. All we needed to find was a. All right, doable. Okay, I have one last little comment. I'm going to give you guys time to work. Here's the deal. I don't think it's going to take you 25 minutes to finish. So kind of my plan, just so you know, I'm going to give us like 10 or 15 minutes for homework. And then instead of just burning the last 15 minutes of class doing absolutely nothing, we're going to get a head start on tomorrow's stuff, not like as a bad thing, but so tomorrow we can let that homework time in class kind of keep rolling. Cool. All right, last little thing. Out of curiosity, do you guys prefer the vertex form, or do you prefer ax squared plus bx plus c? Vertex is really nice depending on what you're doing with it. There's very few times where I look at something and think, oh, I'm going to go to vertex form. Realistically, I just typically don't. So I want to make sure that we can identify our last little piece, which I don't know if we've said this word in here or not. Have we ever used this word, extrema or extrema? Can you remind me what extrema are?
Like top and bottom, the biggest ones.
Good. What's the biggest, like, if this is the biggest value of my function, I wouldn't say it's the biggest, I would say it's the, ooh, I love that. So I do remember talking about global, or what's the other word we could use for global? Absolute. The global or the absolute, min or the max. Now, with quadratics, you're never going to have both, right? You'll have either a minimum if it's an upward smiling parabola, or you'll have a maximum if it's like this. These are our extrema. Now, first comment. We know that they occur. Is that spelled wrong?
No.
No, it's
You just said
Oh my. All right. Hio is what I should have said. Occur at where? If you have a quadratic, where are you going to find the minimum or the maximum?
vertex.
Good. Vertex. Okay. If you need it, HK. And it's really easy to identify if it's in standard or vertex form, right? However, you're not always going to be given that standard form with the vertex and all that written out. And maybe it's not always worth the time to find it. So we're just going to make sure that if we're not in vertex form, we don't have to deal with it. Given our general form, which I'll just use, I'm going to use f of x instead of y, very specifically. If instead of vertex form, I give you ax squared plus bx plus c, and all I'm asking is for the min or the max. I know if it has a minimum, depending on the value of a, or if it has a maximum. It would have a minimum if a is what? That would look like this. Is that a minimum value up here?
Yeah. Negative.
That's a max if it's there, right?
Oh,
If a is big,
positive.
positive, you have a minimum. If a is negative, it looks like this and you have a maximum. It just opens downward, has a maximum value, opens upward, has a minimum value. And instead of just drawing it with my hands, this is a downward parabola. Is that a min or a max? This is negative a. If it opens like this, is that a min or a max? And that's a positive a. That's all that we just hit.
wait, how's that positive now and negative?
So positive a value here just means that my parabola will open upward. It'll be a smile. If it's a negative a, so like just like if we imagine positive x squared, did it click?
Yeah.
Okay. All right. So that aside, I can tell if it has a min or a max. Why would I not just do this? I can tell if it has a min or a max based on the value of a. If you don't want to have to go through the whole process of completing the square because your numbers are ugly or you're lazy, doesn't really matter what the issue is, we have the following. The vertex can be found in this form at a very particular point. Now, you guys might remember it, you might not. You'll probably have at least some memory of the quadratic formula here. If you don't want to have to go through all of this process of completing the square by adding 0 and all that good stuff, you can always use the following. Turns out the vertex is always at negative b over 2a. That's my x value. And f of negative b over 2a. I don't know that I would really say that this is easier all the time than getting into vertex form, but it is an alternative option if all you need is the min or the max. Okay, we are going to do 1, and whether you write it down or not is up to you, but I want you to help me find the vertex, and I'm just going to call it the extrema instead, extrema of, and let's make up a function. F of x is 2x squared minus x plus 3. All right. Real quick, am I going to find a minimum or a maximum?
Minimum.
Why?
The A is positive.
A is positive, which means it's a smiling parabola, which has a smallest value. Okay, so I know that there's going to be a minimum. Can you guys tell me what A, B, and C are on this? And I guess I don't even need C. Can you tell me what A and B are? Ooh, I heard 2 different answers. A is what? 2. B is -1. Everybody all right with identifying those? All right, so let's check this out here. I need to find f of negative b would be what? A positive 1 over what's 2a? 4th. Okay, here's where, again, I don't know that I would always suggest doing this, but it is available. It's faster if all you need is just a single point. This literally means anywhere that I have an x, I'm going to replace it with a what? A 1/4. So let's just check it. Here it is. Here it is. And I need your guys' help because fractions are our friends, not decimals. How do I square 1/4?
Just times it by solve.
So 1/4 times 1/4?
1/8.
Try again.
1/16.
1/16. I think that's just a typo. I don't know if that's the right word. Minus 1/4. How do you want me to write 3? Do you want me to just write 3? Should I write 12/4? Maybe I should do it in eighths because I see what's going to happen. I'm just going to write 3 for now. We'll decide. Okay. There's a bunch of right answers, just so you know. How do you guys do this?
Just 2 over 1 times 1 over 6.
So you guys call this 2/16? I do it slightly different. You call it 2/16 and then you simplify. Can I simplify it first? Have you guys ever done the simplifying first? Okay. I normally do. What I'm looking at is I know that this is 2 over 16, right? Is there anything that goes into 2 and 16?
8.
8 does not go into 2. But a 2 goes into 2. How many times? And how many times into 16? So what's the easier way to write that fraction? 1/8 minus, can I make this an eighth now? How do I change 1/4 to something over 8? 2/8? Plus, how do I make this something over 8? Times 8 over 8, I think it's 24/8. Cool. Last step. They all have an 8 in the numerator, that's easy. What's 1 minus 2? Plus 24. Positive, I believe. Check it out. Now, we didn't really truly answer the question yet. We have our answer on the board, but we have to make sure that we are clear with the way that we write them. We are looking for an extrema, and you guys have already answered it, but I never wrote it down. A min or a max? So this has a minimum because A was positive, right? A minimum value. What is the value that we've just found? 23/8. When, what was x?
1/4.
Love it. This is the more clear version of just writing the ordered pair. Cool. Whether you use this or not, I really don't mind. If you didn't do it this way, you certainly don't do this problem. But the other way to do this would have been to try to complete the square with this mess. Big blank space plus 3, and we could find whatever the h would have been and the k would have been. It's more complex though. Okay. Both are fine. Both are options. We're really doing the same thing. Whichever one you decide to go with is good with me. I'm going to give you guys until 20, so that's like 13 minutes. You get the next 13 minutes to continue working on the assignment from yesterday, asking questions of me, your neighbors. Cool. All right. We will pick back up and lecture for the last 10 minutes of class. Baller. Start of a new one. So welcome back. We're the same day. Homework is going well, seemingly. And let me zoom out so I can make sure I'm on a right good spot. Okay. Put that there, and then we'll go right in the middle. Deal. All right. So we started our section talking about quadratics, right? And quadratics are just a special case of a bigger, fancier name of a type of functions. What do we call the whole section? We were snuck a definition in the very beginning of our notes a moment ago. Something nomials. Polynomials. So quadratics are just the easy polynomial. Now, linears could also be considered as such, but they're less interesting. To start the second section, we're going to be looking at 2.2. And in 2.2, we are going to be looking at polynomial functions. So I'm going to call them polyfunc of higher degree. Now, I don't know how much graphing you guys have done with x cubed and x to the fourth and all that. Once you have the basics of how do we make a table, the rest of it's pretty whatever, to be honest. You can make a table, you can plot points. I do not have a strong opinion of making guys find like 50 points to plot them all and then trace a line. I don't think that's a good way to do math. There are a lot of really easy ways to graph a lot of these functions. We'll see the easy ways when you guys take calc. A pretty big focus is making sense of how do we graph these easier than all those points. And it's a big point of like, what do we look at? However, we're not in calculus yet. So instead of doing that, we're going to first start talking just about the graphs of polynomial functions. Now, whenever somebody thinks of the name Holloway, undoubtedly you think, man, that guy's probably a pretty good dancer. I can tell. I'm not, just for the record. I can swing dance like country dance, I can do that, but it's so much shoulders that any other dance that I try to do has too much shoulders in it, and then it just looks silly. But that's okay. As we look at these functions, there's two fundamental things that happen with all of them. All polynomial functions, all are, I'm going to write two statements. Okay, the first of this is continuous. Now, there is a very rigorous definition that we can use for continuous, but for ours, we're just going to go with like the nice chill version. If you can graph a function, and I don't need you to write it, I just need you everybody to listen. I'll wait until everybody's done writing because you're catching up. Continuous for us just means can you draw it without picking up your pencil? There's no holes in your graph, there's no asymptotes. Now, there's always a weird one. This function, and I'll sketch it up here because it's worth having. And a quick question because I want to make sure that I don't leave any room for loophole. This is just, you don't have to draw it, I just want to talk. This function, is it continuous? There's a clear discontinuity right here. Okay, but check it out. When I say you can draw it without picking up your pencil, I definitely do not mean doing this because one could. Like, just to really clarify, that is still discontinuous because the hole you couldn't really draw it. We use that to represent it. Everybody cool with that? Okay, so they all have to be continuous. The second thing that we need is every polynomial function that we ever deal with will be continuous and it'll be a smooth curve. Okay, they won't always look like it for sure, but you guys tell me if you like this parabola that I'm about to sketch that maybe doesn't fit that classification. There's a parabola that exists where I probably get these points. You guys know that it looks like this when we draw it. Roughly. Anybody remember ever graphing parabolas like this? Nope, because you didn't, and you won't because parabolas are polynomials. They're smooth curves. They don't have sharp corners. Now, there's a random exception where if I have a really skinny parabola, it might be hard to make it look like a smooth curve down here, and it might look pointy, but that's just because it's an ugly graph. All of them are smooth. All of them are continuous. All of you are cool with that. All right. So then with this, there's a few different things that we'll have to deal with, but there's only really two options that I want us to consider. And we're going to be looking at end behavior and stuff. I will teach you guys a sweet dance with this. But we're going to jump right in. Graphs of polynomial functions. Turns out it's pretty easy to decide what they're going to look like. we are going to have what is known as the leading coefficient test. Did somebody just give a groan because of what I just said, or unrelated?
No, what's the thing?
Okay. You will likely never see me write the leading coefficient test with these words again. What am I going to replace leading coefficient with? LC, 100% of the time. Okay. Only two possibilities that happen. Now, there's really four, but let's talk about this. The leading coefficient, if all we're looking at, it can either be a positive number or a negative number. Those are the only two options. Because if it's 0, then it's not really the leading coefficient. Okay, everybody okay with two possibilities? Okay, when we talk about the degree of a function, does anybody recall what it is we're referring to? The highest power of the variable. Okay, the degree can only be one of two things. It can't be negative, because that would make it so we have something dividing by a variable on the bottom, which isn't allowed for polynomials. Remember, you don't have to write it, but they all have this form. And it's that big, ugly looking thing that's really not ugly at all once you see how it works. All of these numbers are integers. That is what I care the most about. And even I'll go further than that. They are the natural numbers, positive integers. Okay, there's only two options. I'm going to list a few of them that all have something in common, and I want you to tell me what that commonality is. 2, 6, 12, 28, 54. Those are all the evens. Okay, that's one very specific situation. So all the powers are either going to be even or odd. We're going to summarize this real quick. Leading coefficient test. This is really for end behavior. Now, same thing. You can probably guess, how is Holloway going to shorthand end behavior? EB, 100%. All right. We're going to learn a little bit of calculus right now. Like, realistically, you know what it is calculus, whether you're aware of it or not. But we're going to learn a little bit. If I ask about any old function, and I'll just sketch one up here. And, hey, I already have a graph. Does that thing have a smooth, you don't have to sketch it, I just want to talk about it for now. Does that thing, is it smooth?
Yes.
Can I draw the whole thing without picking up my pencil?
Yes.
It's a polynomial. Okay, if I asked you what happens to my function as x goes to infinity, can you tell me what my graph is going to do? For how far? Do we agree that as the x goes to infinity, the function also goes to infinity? Okay, now you don't have to write the calculus stuff, but all that we've just determined was the following, and it's just nice to see it. If I asked you what is a limit as that number x that we're plugging in goes to infinity, like, does my function get limited? You guys just told me that as I move infinitely far to the right, it does what? So if I said as x goes to infinity, my function, that's what I'm asking what happens. How big does it go? Do you guys agree that this notation looks scary, but all it means is as I go really far to the right, my function goes really high up? Okay, this is a calculus concept. In fact, this is what we spoke about in calculus for the first 3 weeks of class, limits. Okay, tomorrow we are going to get a table for end behavior right at the start of class, and I'm going to actually have your bell ringer asking you to do a little investigation with your calculators. Cool. Bring your calculators or be prepared to grab one there tomorrow. We will check the homework and do some graphing stuff. Do you guys like or hate graphing? So that wasn't like hate. Maybe you don't love it, but that's okay. All right, later Raiders.